7.1, we are going to cover exponent rules. So you've seen these in grade 9 and grade 10, and now we're going to actually just investigate patterns with exponents. Okay, so first, multiply powers with the same base, and this same base is going to become very important when we actually do questions and recognizing whether or not we can use the exponent laws. Okay, and so we're going to complete the following table. So product, let's find the expanded form of 3 to the 5 times 3 to the 2. Okay, so what does 3 to the 5 look like? 1, 2, 3, 4, 5. Okay, it looks like 3 times 3 times 3 times 3, 5 times. Okay, now we're going to multiply it by 3 squared. So that's just 3 times 3. Okay, so how many factors are there? 1, 2, 3, 4, 5, 6, 7. There are 7 factors, and therefore we can just rewrite this as 3 to the 7. Okay, let's try the next one. 5 squared, well, we know that's just 5 times 5, and multiplied by 5 to the 4. So let's write 5 4 times. 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5, 6. Now there are 6 factors, so this actually becomes 5 to the 6. Okay, let's do negative 2. Negative 2 to the 5 is negative 2 times negative 2 times negative 2 times negative 2 times negative 2, then times negative 2 squared. So negative 2, I'm going to put one back here so it fits, negative 2. This is much bigger than maybe a pencil on your paper. Okay, and now let's count. 1, 2, 3, 4, 5, 6, 7. There are 7 factors, so this one is going to be negative 2 to the 7. Okay, and then keep the brackets. You may want to write brackets. Okay, keep the brackets, and we're going to get into why those are important. Okay, and you can go ahead and try the next two. I'll just quickly put those on the board. So we're putting negative 3 on the board 4 times, and then another 3 times. 1, 2, 3, 4. So that's negative 3 to the exponent 4. And then negative 3 to the exponent 3 is 3 more times. Let's write this here. 1, 2, 3, 4, 5, 6. Oh, 7 again. Maybe I like 7s when I make up these questions. So this becomes negative 3 to the 7. Okay, and you do it for 1/2 as well. Okay, I wanted to show you at least one fraction here. So when we expand it in expanded form, we have 1/2 times 1/2 times 1/2. And then this has an exponent of 1, so we just write it 1 more time. Okay, so that will be 1/2 to the 4. What do we notice? We notice that this number here, let's highlight with green, this number here reflects these two numbers added. Okay, so write a rule for the product of 2 powers with the same base. Okay, so here's an actual rule, a to the m times a to the n. What we do is we add the exponents. Okay, or we can write it in words when we have the same base. And multiply. We can add the exponents. We add the exponents. Divide powers with the same base. So I pretty much took like almost the same numbers here, and instead of writing them as multiplication, I wrote them as division. Okay, so let's write expanded form of 3 to the 5. So we know that's 3 times 3 times 3, 5 times. Oops. Okay, and then we go divided by, and then 3 squared, so 3 times 3. So here's the thing. When 3 is divided by 3, it equals 1. When 3 is divided by 3, it equals 1. So those will both cancel out because it's just like multiplying by 1. So now there are 3 factors left. So our answer is 3 to the 3. Okay, So let's go 5 times 5 on the top, which is 5 squared. And then let's write 5 4 times on the bottom, because it's 5 to the power of 4. Okay, so 2 on the top, cross out with 2 on the bottom. It leaves 1 on the top. So it's actually like 1 over 5 times 5. So the number of factors, let's write it one number of factors, let's say 2, and then write it as a single power 1 over 5 squared. Let's write it like that for now, and then we're going to get into negative exponents. Okay, so negative 2 to the exponent 5, let's go ahead and write that 5 times. And negative 2 squared. Okay, again, if everything's multiplied on the top and then everything's multiplied on the bottom, we can cancel these out. There are 3 factors, so our answer is negative 2 cubed. Okay, let's write negative 3 4 times and then 3 times. And this is really good practice. Even if you remember the exponent laws, this is good practice because when we're dealing with numbers and we have to multiply, especially fractions, these are going to come into play. Okay, so let's cancel out. And we're left with 1, negative 3. So negative 3 or negative 3 to the 1. But this right here is imaginary. So you don't have to write it. Okay, now 1/2 to the 3 on the top. So let's write 1/2 3 times. And let's just write 1/2 once on the bottom. So we cancel these out. We have 2 left. It's 1/2 squared. So when looking at these two numbers and then this number here, maybe this number here actually, the number of factors left, what do we notice? So 5 and 2 and then 3, 2 and 4 and then 2, 5 and 2 and then 3. Okay, well we notice that a to the m divided by a to the n, what we do is we subtract the exponents. So when we have the same base, we subtract the exponents when we divide the numbers. Last one that we're actually going to go through and investigate. They're the ones I'm going to provide rules for us to remember. Okay, so we're going to find the power of a power. I like this. Let's call it power of a power. Okay, so 3 squared 4 times. So we need to write 3 squared, which is 3 times 3. And we need to write that 3 times 3 4 times. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 factors, so this becomes 3 to the 8. Now let's write 5 squared 4 times. 5 times 5, 5 times 5, 5 times 5, 5 times 5, which is also 8 times. So this becomes 5 to the 8. Now let's write negative 2 squared 3 times. Negative 2 times negative 2, 1 time, 2 times, 3 times. So 1, 2, 3, 4, 5, 6. This becomes negative 2 to the 6. Okay, let's write 6 to the 5 twice. 1, 2, 3, 4, 5. Let's write it again. 1, 2, 3, 4, 5. So we actually wrote 6 10 times. So that becomes 6 to the 10. Okay, and now let's write 1/2 to the 3rd, but 3 times. So 1/2 times 1/2 times 1/2. That's 1 time. 1/2 times 1/2 times 1/2. That's 2 times. And 1/2 times 1/2 times 1/2. And that's 3 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1/2 is written out 9 times. Okay, so when we have a base to the exponent m, and that's the exponent n, what we're actually doing is we're multiplying the exponents. So 2 and 4 is here. Well, 2 times 4 is 8. 2 and 4 is here. 2 times 4 is 8. 2 and 3 is here. 2 times 3 is 6, and so on. Okay? So we can say multiply the exponents when we have power to a power, or of a power. And that's that rule. So let's test our rules by simplifying these expressions. So our rule was when we're multiplying the same base, we add the exponents. So 6 to the 3 plus 2, let's go 6 to the 5. Okay? And you can go ahead and check your rules by entering first this into your calculator and then this into your calculator, and ensuring that you come up with the same answer. Okay, same base, 5, and we're multiplying, so it's 2 plus 4. Okay, when we multiply, we actually add the exponents. Same base, so it's 10, and it's always the first exponent minus the second exponent. That's important because a lot of students just take the positive exponent, but in these cases, it's always the first exponent or the numerator minus the denominator. Okay, same base, 7 to the 6 minus 2, 7 to the 4. Okay, and these two examples here are power of a power. So 4 times 2 is 8, 2 times 2 is 4. All right, so here's everything in one shot. Law of multiplication, a to the m times a to the n is a to the m n plus m. Sorry, we add those. Law of division. What we do is we subtract them. So a to the m, we have m minus n divided by a to the n. Power of a power. This is where we multiply those two. Okay, power of a product law. So I'm just going to expand this, and we expand this AB, m times. So I'll just put dots. Actually, just to show you, but the m actually applies, it's a to the m and b to the m. Okay, power of a quotient law. This m goes on both the top and the bottom. So a to the m over b to the m. Okay, and now let's take a look at powers of a negative number. So this is really important, and this is where a lot of students get this wrong, but the exponent only affects the number that it touches. Okay, so let's actually take a look at the difference. So this 2 is only on the 3. So it's negative, and then we're taking 3 squared, which is 9. Whereas this 2 is on the entire negative 3. So this one's actually positive 9. The first one would have been like negative and then 3 times 3. Okay? So it's going to make the difference between a positive and a negative number, and depending on what we're trying to accomplish in a question, it's going to make a huge difference. Okay? So this 2 is only on the 2. So negative x minus, and then what's 2 squared? 4. Okay, this 2 is actually on the entire bracket, x minus 2. And we've learned to actually do x squared minus 2x plus 4. And we learned this back in the quadratic unit. So the answer, these two answers are very, very different, and it depends on where the bracket is. Okay, so again, the exponent affects only the number it touches in the power. Go ahead and try these on your own. I know this is reinforcement from, again, like grade 9, grade 10, and then I would come back here and see if they're right. And I'm gonna fly through these a little bit quicker, okay? So we have 2x cubed, so we know that this is 2x, all written out 3 times. 2 times 2 times 2 is 2 and 2 is 4, 4 and 4 is 8, and then we have x cubed. Okay. We have 3 to the 4 written out 3 times. This one's important because a lot of students forget that when we multiply this exponent, it goes to the top and the bottom, and I'm just showing you how that applies. So 3 times 3 is 9, times 3 is 27. 4 times 4 is 16, times 4 is 64. Okay, so we multiply the numerators and then we multiply the denominators. Okay, we can use the actual rule by putting the 3 on the 5 and on the x. Okay, so 5 to the 3 is 125 and then x cubed. So you can do it that way as well. The 4 is on the numerator, the 4 is on the denominator. 2 to the 4 and 3 to the 4. 2 and 2 is 4, 8, 16, 3, 9, 27, 81. Here we go. Okay, so I'm going to write this as negative 3 to the 4, and then we have x squared to the 4 as well. So I'm going to put this 4 on the first term and the second term. Okay, the first term turns into 81. You can put that into your calculator. And the second term, this becomes x to the 8. Okay, so we have to be very careful with this one. These have the same base, which is 2. So let's go, let's write out the first term here, and then we're going to multiply it by, this will be 2 to the 5 plus 3 is 8. Okay? But what's 2 to the 4? And you can do that on your calculator if you want. Which is we get a 16 times, and what's 2 to the 8? 256. And this negative sign stays there, so we get negative 4096. Okay, division, 3 to the 4 over 3 to the 5. I just rewrote it, so you can see we have to subtract 4 minus 5. Okay, so 3 to the negative 1. Okay, we have the same base here for all of these. 3a is our base. So with division, we subtract 2 minus 5. Okay, and then I'm just going to write that underneath. So we get negative 3. So we get 3a to the negative 3 times 3a to the 6. And with multiplication, we add. So it's negative 3 plus 6. We get 3a cubed, which is also 3 to the 3, 27, a cubed. Okay, all 3 of these have the same base. So with division, we subtract. So we are going to do 12 minus 5. Okay, and then we're going to multiply that by 3 squared. So we get 5, 6, 7. 2 to the 7 times 2 to the 3. Okay, now since this is multiplication, we can collect those. So this is 2 to the 10. And we could just leave it as 2 to the 10. Okay, last 3. J is a little bit like F, so I'm going to show you a little bit of a different method. Let's keep that negative there. We have 5 squared and 5 to the 5. So this is going to be 2 plus 5. So this is negative 5 to the 7. Okay, these two numbers we're going to add, 3 plus 9. So we get negative 2 to the 12. And the last one, I'm going to put this number 3 onto all 3 of these. So we're going to get 5 cubed, we're going to get x squared cubed, and we're going to get y to the 7 cubed. So we're going to get 125x multiplied Okay, and then we're going to multiply these, so y to the 21.